All right, class. I apologize for how I sound. I got more sick last night, so making this video right now. It's like 7:08 in the morning for you guys, so you could watch it. Today we're doing logarithmic functions, and what is a logarithm? It's basically another way to write an exponent. Okay, so another way to write an exponent. A logarithm is also the inverse of an exponential function. So remember exponential form, we said it's like f of x or y. We'll just, I'll use y's for this. Y is equal to a to the x. Logarithmic form rewrites this so that the exponent is what you're equaling it to. So if you look over here, the exponent is x, so it's x equals log, and then you put the base here, so the base is a, and then you put the final letter or number or whatever it is there, so y. So this is the form for that. You always equal it to the exponent, and then you write log base, and whatever the base of the exponent is goes there, and the other thing goes there. Let's look at a problem real fast. If I have 5 squared equals 25, I can rewrite that as saying, well, the exponent of 2 is equal to log base 5, 25. So the way to look at this is, what exponent gets you from 5 to 25? Well, that exponent is 2. So that's how you would write that. Now, a natural log is the ones that have base e. So, for example, if I had something like y equals e to the x, no, e to the, yeah, we'll go e to the x. You can write that as the exponent x equals log base e of y. But we don't use log base e. And so whenever you see a log base e, that really is the same thing as a natural log. So when you see that ln button on your calculator on the far left, it's a natural log. A common log means it has a base 10. Okay, so for example, if I said y equals 10 to the x, we would rewrite this in log form by setting the exponent equal, so x equals log base 10 of y. Now, when you see log base 10, you will never actually see this. This is the actual log button on your calculator. Where you see log, that's already log base 10. So when there's no number there, you assume base 10. And this should say base e for that. Okay, so excuse me, those are all the forms. So now we're going to just rewrite it. So the first thing I do is identify the exponent. So we're going to say the exponent is equal to log, so you just write log, and then it's the base. So the base of the exponent was 3. So it's base 3, and then the rest of it is the 1/9. Okay, so that would be how you rewrite it. This one over here, again, we're setting it equal to x, because that's our exponent, is equal to log base e, because that's what the base is, of 2. Remember though, we can rewrite this as x equals natural log of 2 because it's base base e. Now to rewrite in the other form, I do like the spiral method. I say, okay, this is my base number, that's my exponent. So 6 to the third equals 216. And sure enough, that's what it is. Now remember, when there's no number here, you have to assume base 10. That's our common log. So we would say 10 to the second power is equal to 100. And that's how you rewrite it. So now we're going to evaluate without a calculator. Here's what I do to evaluate without a calculator. I just set these equal to x because I want to know what these are. I want to know what the exponent is that gets us from 2 to 8. Now some of you guys can just tell me that. Basically, to read this, what exponent do you have to raise 2 by to get to 8? And hopefully all you guys are thinking, I think it's 3. And if not, that's okay. What you could do is say equals to some exponent, And then you can rewrite it and say, well, 2 to something equals 8. And then you can do what we did yesterday where you break them down. But you guys should know that this is equal to 3. Same thing here. What do we raise 9 to get 3? Well, since we're going down, it's 9 to the x equals 3 to the first. 9 becomes 3 squared. 2x equals 1. X equals 1/2, which is the same thing as saying I'm taking the square root. So that should make sense. Okay, so now we're going to talk about the parent function of a logarithmic graph. Again, when you rewrite it, it's log base A of x. Okay. The common points for this, there's now a vertical asymptote at x equals 0. The point flipped over. Remember, for exponential it was 0, 1. Now the common point is 1, 0. And you're approaching the vertical asymptote down here. Which means for these ones now the domain is that x is greater than 0 and the range is all real numbers. Because remember, inverses switch. Okay. Now with these graphs, the argument, which is the piece inside the log, this piece right here, which is the piece inside the log, must be greater than 0. Okay? So that'll help us find domains, because think of it this way. The domain is always greater than 0 unless there's a horizontal, a left to right shift. So let's look at these. So now we look, this was shifted right 1. So we would say, well, x minus 1 has to be greater than 1. I'm sorry, greater than 0. You basically are setting whatever's in here greater than 0. So the domain for this one would be x has to be greater than 1. If you look at the log piece, all we have is the x. So for that one, all you have to say is x has to be greater than 0. There's no shift. So those are the domains. That's all you have to do for domain of logs. Just take the piece that's the log of, not the base, but the other piece, the argument, and then that has to be greater than 0. Finally, we're going to solve. So it says find a, so that we have the point A2 on the graph. So we're going to plug in 2 for the y. So 2 is equal to log base A of 8. Okay. It's hard to see what this is, so what you want to do is rewrite it. If you can't figure it out from this form, rewrite it in exponential form. So this is a squared equals 8. Okay, well, if I told you x squared equals 8 and told you to solve that, hopefully you guys would go, oh, I have to take the square root of both sides. So a is equal to the square root of 8, or if you want to simplify that, that's 2 root 2. Notice I did not put a plus or minus. That's because the base for a log is always positive. So no plus or minus. Okay, so really the key here today is please practice going back and forth between the forms. That's the most important thing from the worksheet today. All right, hopefully I get better. Hopefully I see you guys on Monday. I'm pretty sure I will. If it's not 2017, then I forgot to update this video, and you guys are probably very confused right now. So anyway, have a good weekend, and I will see you guys on Monday.